does that number look like right there? All right. You see that? So this is just the first example of what I'm talking about, and that's why this silly thing right here is up in everybody's lab. I'll turn that off so the camera can see that. Is because there are so many things that if you know what you're looking for, they just come right out at you. Now you may say, well, what about hydrogen? Well, over here is hydrogen. One of the things you're going to know about hydrogen, it is always pathological. Hydrogen does everything weird. Okay? I've taken a whole half of classes on hydrogen. I mean, I promise. Sometimes hydrogen behaves as a metal, sometimes it behaves as a non-metal. Look at that. What would you have said about hydrogen? Is it a metal or non-metal? Before I told you it did both. Non-metal. Why would you say it's a non-metal? It's obviously on the left of that stair-step line.
I've just never heard of it
right?
as a metal.
Oh, you've never heard of it as a metal? Well, what about HCl? There, hydrogen's behaving as a metal. It's written first. Anytime something's written first like that, this hydrogen here is considered, quote-unquote, a metal. But in a compound like lithium hydride, it's considered a non-metal. All right? In a compound like methane, it's considered a non-metal. You see, I'm just giving her the runaround. Most of the time, hydrogen is considered a non-metal. But it's pathological. It can go both ways. All right? So hydrogen always is trouble. So if you look at this right here, this contains 6 of the diatomics, but you always got to remember to throw the hydrogen in there. Are we happy? Okay, there's 2 others that you have to know, and that is called and there are only 2 others, S8 and P4. And these are called what? If you got monoatomics, diatomics, what do you think these are called? What's that? What'd you say? No, I didn't hear you. Triatomics? Now, triatomics would be something with 3 atoms. Okay. This right here they generally call polyatomics, which means more than one. Now, a triatomic is polyatomic as well. Okay. This octaatomic, octagon, that's polyatomic. But they generally just group those into a polyatomic. So what happens if you get eyeball to eyeball with sulfur, right, on your microscopic spaceship? You would see something that looked like a stop sign with sulfur atoms on each corner. That's what that would look like if you wanted. It would be like a ring structure. And phosphorus, if you got eyeball to eyeball with that, it would look like a square with all the phosphorus bonded together in a square. That's it. Everything else is monoatomic. So you see why I'm telling you. Do not memorize the ones that are monoatomic. Memorize the diatomics, these 2, and you're done. Everything else, if you ask how it naturally exists, okay, naturally existence. Is there any questions about that? Okay. Now, let's talk about what form things exist. So how do things exist typically? What are the forms? A solid, a liquid, or a gas. Is there anything else? Nobody wants to say anything else? Okay, solid, liquid, and gas is what we'll talk about. There is something called a plasma, but let's just do solid, liquids, and gases for right now. Okay, color code this periodic table. We are talking about room temperature, which is considered to be 25 degrees centigrade, and atmospheric pressure, which is considered to be 1 atmosphere right here, sea level, Jacksonville, Florida. Okay? So we're not going to crank up the temperature. We're not going to freeze something. We're not going to put up a huge pressure. We're talking about room temperature. If it's black lettering, I'm talking about black lettering, not black compounds, right? Because these things are certainly silver and orange and everything else. Black lettering means it's a solid, naturally, at room temperature. Okay? So pretty much if someone says list a solid, then you're going to have a pretty good shot. Because look at this. What are most things up here? Solids. All right, most things are solids. Most things are black. And on the handout I'm going to give you, it's going to say, okay, list for me the liquids and list for me the gases. All right. Now, what are the liquids? Blue. Mercury is a liquid, And again, this is a color code designation on this lecture here, right? I don't want to misconstrue that you think mercury is a blue liquid. The blue lettering means this is a liquid. It's a silvery metallic type liquid, and so is bromine, Br2. A lot of times they use bromine if you're just looking for an everyday common use for it. They use it to disinfect like hot tubs. It tends to be a better disinfectant than chlorine. All right. But bromine and chlorine both are what are called lacrimators. Do you know what a lacrimator is? An onion's a lacrimator. Does that help? It makes you cry. The lacrimal ducts, it makes you cry. All right, so if you're trying to do a bromination reaction or something, if you use straight Br2, you get that up your nose, I mean, you sit there and start crying and everything else, right? It's a lacrimator. It makes you cry uncontrollably. Okay, so that's that. Now, gallium, they don't have it in this periodic table, but that also is another element that is considered to be a liquid at room temperature. Kind of. Let me tell you why. All right, let me get sexist here for a minute. If you're a woman, how do you like your room temperature, hot or cold, versus a guy? Generally, hot, warmer. And a guy generally likes their room temperature cooler than women. Okay, chemists were no different. So in a gallium lab, I had some friends that worked in a gallium lab, and when women come in, they would crank up the thermostat 2 or 3 degrees, right? They wasn't stupid about it. They just 2 or 3 degrees up. And the guy was, again, not stupid about it, 2 or 3 degrees down. Well, guess what the melting point of gallium is? Right at around room temperature. It kind of depends on how hot your temperature is. So some days in their lab they would have solid gallium, and some days they'd have liquid gallium, which of course you can imagine is a huge problem, right? Because scientists, we're all about reproducibility, right? So if you run a set of experiments and you're using a solid, fine, but keep it solid the whole way through, right? Same with liquids. If we're using liquids, great, but keep it liquids. So there had to be some intervention done about not tinkering with the thermostat, all right? But that is another known one that you could put for liquid. Some textbooks say so. To be honest with you, I'm not sure what your textbook says, so whatever, okay? Now red. What do you think the reds are? The gases, okay? Of course, hydrogen's a gas up there, all right? Helium, right? You think about that as far as a balloon goes, helium is a gas. Neon, argon, krypton, xenon, radon. Well, heck, it makes sense that a noble gas would be a gas, all right? And now, naturally, do you know what most of the stuff you're breathing right now is? What's that? Nitrogen, right? Most of the stuff you're breathing is nitrogen. Now, of course, the active ingredient is oxygen, but nearly 80% of the air you're sucking in right this minute is nitrogen. Again, naturally, look around. It's a gas. This is a gas. And these two here, fluorine and chlorines, are both gases as well. Okay? And now the fluorine and chlorine, these right here, out of the naturally occurring gases, fluorine and chlorine are extremely nasty. All right? They're electron scavengers, which means if they get anywhere near your eyes or something like that, you got trouble. Okay? Those oxidation reduction reactions are silly. All right? Now, as a gas phase chemist, though, did you know that I really did not care that much about chlorine? Do you know what the gas that scared me the most was that I absolutely hated to work with? Anybody guess? Carbon monoxide was the gas I hated to work with. See, if your regulator breaks here, there's going to be this green thing start forming, and that's going to kill you. Pretty much, if a gas is colored, you got trouble. Hold your breath. You will probably die. All right? And you may say, well, wow, would you not be scared to work with that? No, I can see it coming. But what about carbon monoxide? You just go to sleep, right? So you already saw me. I mean, I almost got, could have been diagnosed with obsessive compulsive disorder because you had these carbon monoxide detectors. So every day before I went to the lab, I would test them to be sure that the batteries was working in them, right? Because if you did have a leak, at least you could hear it. But at any rate. Okay, so those are the gases. So we got one more thing here, and that is this outlined dragging, like technetium, seaborgium, borium, neptunium, plutonium, americium. So what does that mean? That means that those are synthetically prepared. Okay? In other words, you cannot go and find curium in the earth